Can you hear me? Can anyone hear me? Everyone hear me? Anyone there? Excellent. Thank you, Ahmed. I had some problems with the sound this morning, so it's really good that people can hear me. I'll start in a minute when when everyone's here at 4 o'clock. I just wanted to test that before we started. Okay, it's 4 o'clock, everyone. So welcome to this week's session. As I say, I had some problems this morning with the sound, but I think hopefully I've sorted that out. So this week we're going to start to look at the assignment. I'm just going to go through it, give an overview of it, talk a bit about how I can help you, what I can't help you with. Obviously, if you've got questions, etc., but just sort of bear with me. I just want to see if I can share it now. Share screen. So you should be able to see the top of the assignment. Can you see that? Someone just answer me. They can see that. Yeah, excellent. Thank you. Okay. So obviously your assignment's due then, and the sort of admin stuff. Just note that all the admin stuff doesn't come through me. You don't send the assignments to me. You submit them centrally, and then they get sent to me. And things like extensions or extenuating circumstances, if you're sick or otherwise indisposed, you need to go centrally through NCC and the university for that. Not me. I'm just not in control of that. I'm just kind of the academic person rather than the admin person. Okay. Now, the whole point of the assignment really is to kind of try and focus on what I've said before in terms of trying to have a kind of workplace situation where you behave as database developers and you go in and you develop a database for this company. So we've done that by having this scenario at the start where you've got background and you've got some information about how the company organizes their data, etc. And we've got some sample data. And there's a couple of notes on that that are important, that are worth pointing out. So further details of the case study are shown in the documents below. They are a representative example of data and can be taken as representative of a much larger data set. So we've not supplied you with masses and masses of data. We've just given you a sample in here, which we want you to populate it with. You can add additional data if you so choose. And also the other note is important, that the data represented is not necessarily in a normalized state. And it is the job of you, the database developer, to organize the data in its most optimal state. So if we look at the data, just look at some data, even though it looks like we've got some potentially, for example, this one looks potentially like it's a database table, it isn't. Take it as a representation of something like a paper form, and it's not necessarily in normalized state. So your first task is to understand the scenario, look at the data, and then tackle the first couple of tasks, which I'll talk about in a second. Just a few brief things of questions that come up quite a lot before I continue with that, given that we've now got the kind of context of the assignment. The first thing is in terms of what database products that you use. It's pretty open, you know, it depends on what's available to you. As long as it is you that is writing the SQL and not a tool that's doing it for you. We don't recommend that you use Microsoft Access. It hasn't got all the facilities that we necessarily need for this, and it does far too much for you. This is a much more of an SQL based database development project than something that you can do just by using sort of the wizards that are available in Microsoft Access. If you were to develop a real database system for a company of any size, it might be not using Microsoft Access. Microsoft Access tends to be for smaller projects. So pretty much apart from that, things like MySQL or Oracle or whatever are all suitable. Now, the other thing pertains to the first two tasks, well, the first task really, mostly, which I will talk about in detail in a sec. But your first task is to create an entity relationship diagram. And what often happens is each year, and it will happen this year despite me saying it, but hopefully not by the people on this chat, what happens is that each year people send me a entity relationship diagram that they've done, and they say, can you tell me if I'm along the right lines? And what happens is I don't even look at it. And the reason I don't look at it is because there are two ways I can respond to someone sending me their ER diagram. I can say, okay, you're on the right lines, in which case people tend to hear it's completely correct, or it's correct, you know, and that might not be the case. Or, so it's not a very satisfactory answer. Or I can start saying, okay, this entity is right, this entity is right, I don't think that relationship is correct, etc. In which case I'm doing your assignment for you. Because the data modeling part, tasks 1 and 2, are really the heart of this assignment. They are the skills that we are trying to teach you, and you know, someone else doing it for you, or someone else sort of filling large parts of it in for you, means that you're not developing the skill yourself. So that's what will happen if people send me some kind of work in progress. So I don't look at work in progress. Having said that, I still want to be able to help you. So I can help you in lots of ways. I can clarify what's in the assignment, whatever, so people can ask me about that. That's fine. You can ask me questions about data modeling, giving specific examples, but maybe from other scenarios. You could say, for example, right, here's a student record system. We've got this sort of data. How might we sort of model it? So you need to sort of think of other ways of phrasing your questions rather than ask me directly, is this right, when it relates to our particular scenario. I hope that's clear. I will be there to help you as much as I can, obviously, but you know, not to the point of doing it for you. Okay. Now, I want to talk a bit about the first two, or really three tasks in detail today. Task 1 and 2, you should perhaps be working on them at the same time, or at least recognize that they complement each other. Now you should have looked at normalization lecture. I can speak about that again in future if anyone needs any clarification. But I need to say that for this assignment, we only need to go up to third normal form. We don't need the higher normal forms for this assignment. So we're looking at third normal form, not higher normal forms. Higher normal forms we assess in the TCA potentially, but for this assignment, we're really interested in third normal form. And again, when I was working as a developer, that would be the case. You would only kind of look at higher normal forms and checking for anomalies of higher normal forms in certain very specific cases. So up to third normal form is fine for what we're doing today. With regard to the ER diagram, I mentioned this last week, is that we're not using any of the extended ER modeling techniques. So you don't need to worry about subtypes and supertypes. It's just entities and the relationships. Task 1 and task 2 really are kind of looking at the same problem. They're about developing a data model. ER diagramming tends to be a top-down approach. So we're looking at the data, we're looking at the assignment, and saying, right, that's potentially an entity, that's potentially an entity. Normalization, we're looking at the data and we're using particular normalization techniques to group attributes together and eventually come up with some entities. So they should complement each other. And the way that I've phrased the question hopefully makes that a little bit clearer, because I haven't just asked you to do an ER and then do normalization. Task 2 asked you to assess how you've done normalization in helping you develop your data model. So really what you should, one approach to take with this is to create your ER diagram and then maybe do the normalization and see if you're coming up with the same entities. So one task verifies another task. Now, I haven't finished with these tasks, but I'm just sort of skipping back and forth. I don't want an AI. I don't know why there's an AI assistant come up. Go away. Task 3 is fairly straightforward. It says once you've done your ER diagram, you just need to list your tables and show the attributes and identify the primary and foreign keys, and that should match your ER diagram. Okay. Well, I'm just going to skip back now and let's just look at the scenario in a bit more detail. Obviously, any questions about what I'm talking about, just ask them and I'll try my best to answer them. So it's a database system for a company called Azure Lifestyles, which supplies kitchens. And kitchens are made up of fittings and furniture and appliances. And they do it for both individual customers. So, you know, me in my house might order a kitchen from them and they come around and fit my kitchen. But they also have customers who are larger organizations, like housing associations that build lots of houses, or local councils that might build or rent lots of houses, or indeed private developers who might build and furnish lots of houses. And so we've got these different types of customers: private, housing, council, private company, or other. What this means, and this has implications for things like addressing. If you look below, if I'm buying a kitchen for my house here, the delivery and of those and the installation and whatever of that will happen here in my house. Is my address the same address? If, on the other hand, I am a housing association with 200 properties all over, the business address of the housing association is not going to be the place where all the different kitchens are fitted. So those sorts of companies might be fitting in lots of different addresses, and that's kind of shown when we see, for example, where have I got it? I've missed what I was going to say. Where is it? Here in the deliveries, for example. Hanson Housing Association has a customer address, that will be their office, and a different delivery address. Presumably that's a site where they're building some houses and they want kitchens fitted. And you'll notice that some of the customer addresses and delivery addresses are different to each other. And again, where you see one thing, like an order for a delivery, where you have two of something or more than one of something, that should kind of start make you thinking about normalization, about splitting up data that in here on our example documents is together. Just one point. Okay, they offer a range of kitchens. Customers make orders one or more of a particular kitchen in their range. Again, when you see phrases like one or more, that should kind of leap out at you. Customers make one or more means that a customer can have one or more orders. So we might start to get an idea about potential entities here. Each kitchen model, also known as a kitchen, so we're using some loose terminology here, where they have something called a kitchen model. They also call it a kitchen. Now, it's quite common in organizations for this to happen, where they have they use different terms for what is in effect the same thing. So a kitchen model is a kind of type of kitchen. I might order that particular kitchen to put in my kitchen. Someone else might order the same model kitchen to put in their house, etc. Kitchens consist of a number of components. Again, we've got that kind of phraseology, something consisting of a number of something. This should start making you thinking about, okay, a kitchen and its components are not the same thing. One has a lot of the other. Again, that should start making you thinking about potential entities, potential relationships between them. Components are classified by type. So we have components and we have types of components, and supplied by companies located in different countries. All this information, again, it should be reinforced by the data. So let's scroll down again a bit and look at the data. So if we have a customer here, Hanson House Association, and they've ordered 2 different sorts of kitchens in this particular order. We have a different customer, they're a private individual, they've ordered 1 kitchen. Now, the Housing Association has ordered lots of each type of kitchen, 45 of one, 15 another. How do we handle that? Interesting question. We look at list of components of different kitchen models. Well, we look at this data, it's interesting. We have kitchen model K001 lots of times, because these are different components that go to make up that kitchen, and we have quantities of them. Again, that reinforces what I was just saying about kitchens and components. We have some more details about components, their types, their manufacturer, which country their manufacturers in. Again, all this information is lumped together in one table. It doesn't necessarily, one document, but it doesn't necessarily all belong in one table when we actually think about breaking up the data into entities. This is just component types. It's just a type and description. And this is some more information about countries, different countries, and the port that is used for shipping to our kitchen supplier, and the particular agent at that port. This is, again, information that pertains to it. We have information about deliveries. I'll answer that question in a minute. I have actually answered it, but I'll answer it again. We have deliveries, and note there's only 1 delivery per day, but that delivery might include several different places. As as when something is delivered, they drive around and they go to different places delivering. Now the question was, let me just minimize that a minute. For the assignment, do we need to use the given sample data or create our own data? As I said, you need to use the given data, but you can, if you choose to do so, add some of your own data as well. The given data in the scenario should be enough to populate each of the tables that you create. But if you want to sort of flesh it out with some other data, maybe to enhance your queries, whatever, that's up to you. Okay, is that clear, Pravneet? Yeah, no problem. Okay, where's my assignment gone again? Right, good. Yeah, just don't ask questions. That's fine about this. Now back to the questions. Again, I'm just focusing on these for the moment. Question 2 does not actually, if you read it, ask you to show normalization for everything. It says critically assess the normalization you have undertaken. So it expects that you've done some normalization to produce a set of relations for the scenario, i.e. your entities. You should discuss the process of normalization in general. So give an outline of your understanding of normalization up to third normal form. Briefly, I don't need pages and pages of it. That's fine. But also discuss the specific way in which it has been applied to your work. What does this mean if I'm not asking for you to show all the normalization you've done? You can show some of the normalization you've done. So you'll have created an ER, or you've done these two in tandem, and you can go, right, okay, look at this delivery. I have normalized this document. This is a kind of master detail document. There's one delivery and there's lots of orders for that delivery. Excuse me. This is pretty much the format that is shown in the lectures. This is how I have normalized it. I have, by normalizing this document, I have come up with this number of these entities. That's not a clue about how many. I'm just giving an example. So I've come up with these entities by normalizing it. This is how I did it. This matches my original ER diagram. However, I've discovered that, you know, maybe I need to tweak this or tweak that, or this attribute goes somewhere other than I thought it was. That's fine. So you kind of discuss, you talk about how you use normalization to develop an overall data model. The reason I've put it like that is because task 1 and task 2, we're kind of aiming for the same thing. But I'm not asking you to come up with, you know, 2 separate data models because there's 2 different methods. Task 1 is the ER, is the top-down method. Task 2 is the bottom-up method, but we're aiming for the same data model. Now, while I remember it, I will also point out, in terms of marking this, I obviously have a model answer. When I write the assignment, I have a model answer for it. The ER I have created for this task. If you don't have the exact same ER as my model answer, you will still get marks for partial answers, for coming up with the right entities, even if some are missing, for coming up with the correct relationships, even if some are missing, etc. So this is not an all or nothing thing. You can build a functional database that meets the requirements of the business and therefore the assignment with some errors in it. So don't sort of get too anxious about that. Approach the task as a kind of creative task in data modeling, where you've got these 2 methods, task 1 and task 2, ER and normalization, that are aiming for the same end product. Okay. Has anyone got any questions about those tasks before I go on? Task 3 is fairly straightforward. Just list your table name, show the attributes that belong to that table, show the primary keys and foreign keys. This should match your ER diagram. One final thing, because this is something to me that's trivial, but students get quite anxious about it. I'm just going to highlight it. In task 1, please state any assumptions that you make. What does that mean? It's really not something for you to worry about. And you don't have to state any assumptions. What it is if you think something's ambiguous in the scenario, or that might be understood in different ways, or you've made what you think is an assumption about the data or the data model that you're not sure about, or, you know, something like that, you can state here, I have understood that. I don't want to give an example out of this, but let's give an example from our student records system example from last week. If you remember, we had the students and the modules, and we had like the student taking the module entity in the middle. And I said, this will work as a primary key, student ID, and module code will work as an ID if we assume that students can only take the module once. Now, if you were given such a scenario and it wasn't clearly stated whether students can take the module again, and you modeled it like that, you could say in that instance, I have assumed that students can only take the module once. Therefore, student ID and module code are sufficient to be the primary key of student taking module or student module. Yeah. So if there's anything like that, and this really goes throughout the whole assignment, where you're not sure about something, just say how you've understood it, and that's fine, as long as it's sort of reasonable within the given task. So yeah, so please don't worry about that. I tend to always get asked about what that means, and students get sort of nervous about, oh, do I need to say something here? It's kind of a get out for people to say, well, I'm not clear about this. I've made an assumption. I've assumed that this is what the data means in this sense. Just say it. And then, it makes it very difficult for me to say, no, that's wrong. The students understood the data in that way, as long as it's, again, within the remit of the example data and the scenario. Now, I will go on. I'll go over these other tasks in more detail next week. Now, we can come back to any of the tasks at any time if people want more clarification. And I'm sure people will, in terms of once you get to know the scenario, etc. But we've got 5 minutes, so I will carry on with this for the last 5 minutes. Again, if you've got any questions, just ask me. The task 4, we start getting to the SQL tasks. Again, it says database management system of your choice, but not Microsoft Access. We want you to demonstrate that you can move from the entity level to the table level via SQL by writing SQL create statements for all your tables. And we want you to do this yourself, obviously, not get a tool to generate it for you. You should provide screen dumps of this. So by screen dumps, it means an actual screen dump of your create table statements running in your database window. So not a word process document, not in the sense of not just typed up a typed up create statement in Word or something, but in your document, a screenshot of the create table statement running, and create table statement running, and it showing that it's created the table. What it doesn't say here, but it should be obvious, but isn't always, you should be enforcing in your create statements primary and foreign keys. Now, most database products that I've used allow you to create tables without primary keys, which is against the relational model, but the tool allows you to do it for various reasons. Standard SQL allows 2 ways to do this. It allows you to have in your actual create statement defining the primary key and defining the foreign key, or it allows you to create the table and then use an alter table statement to add the primary key and add the foreign key afterwards. Either is okay, as long as you're enforcing those the primary key and the foreign key on your tables. So either is okay. Again, you just if you use alter table after you've done create, you just need to show the screenshots of that to show that you've done it. With all these, I'm going to finish in a sec, so I won't go on to task 3 today. With all these tasks, though, just make sure that you're including screen dumps, because we want you to sort of show that you've actually created the database. Really, you're kind of evidencing it, that you've created the database. Okay, so I'm going to end really in a sec, but over the next week, what you should be doing is focusing on getting to know the scenario and thinking about the data model, drawing an ER diagram, You can draw, in your final assignment, your ER diagram can be used, you can use Word to create it, you can use a drawing tool to create it, you can go and find a specialized UML tool to create it if you want to, but you don't have to. But if it was me doing it, what I would do, I would just get a pencil and paper at the start and start doing my ER diagram that way. There was one more thing I wanted to do. I'm going to share this again because this is important before I go. One thing you can do as well to help verify that your EI diagram is along the right lines is to skip ahead right down to these queries. When you've created your database, you've been asked to do a number of queries. But even when you've just got a pencil drawing or a pen drawing of your database, your ER model, you can come down here and say, right, look at some of these queries. Write a query that selects the kitchens and models being ordered by any customer whose address includes London. How would I do that? Do I need to join tables? If so, will my data model allow me to join tables to answer that query? Again, write a query that shows all kitchens that include components from Germany. What tables will I need to do that? Is the data there in my data model to allow me to answer that question? So by just looking at these queries before you ever even get to them, because eventually these queries will be written in SQL, but just as a kind of mental exercise with a bit of paper, your ER model in front of you, think about, will my model be able to answer these questions? It's just a way, it's just a way of helping you think ahead in terms of your ER diagram. Okay. All right then. I hope that was useful in terms of introducing the assignment. We'll go on going through all the rest of the questions next week, or as many as we can get through, and then we will be focusing on the assignment over the next few weeks to make sure that people do as well as they can on it. As most people who complete the assignments each year do well, so I hope that alleviates a bit of the anxiety people feel around assessment. Okay, I'm going to go now. I have to go out. Hope you all have a good week, and bye for now. And obviously, get in contact with me via the NCC address if you need to. Okay, bye now, everyone. Bye bye.